We've already discussed that if you have 3 points, you have a plane, but if you connect those 3 points, you get a triangle. Triangles fall under the category of simple closed curves, which just means it's a closed figure and we can draw lines and curves to form it. Triangles have 3 sides, 3 angles, and 3 vertices, the plural of vertexes, vertices. And you name it just by naming the points around in order with a little triangle symbol first. So this would be triangle A, B, C. There are special types of triangles. Equilateral means that all 3 sides are congruent. Similarly, equiangular, all 3 angles are congruent. There's examples of both down here. Isosceles has at least 2 sides congruent. Those sides are called the legs. And the bottom side that is not necessarily equal is called the base. These 2 angles would be called the base angles, and the angle up here is called the vertex angle. Next we have a scalene where there's no congruent sides, no 2 sides are congruent. An acute triangle has 3 acute angles, 3 angles that are all less than 90. A right triangle has a right angle in it, 1 90-degree angle. And an obtuse triangle has 1 obtuse angle. The right triangle, the side that's across from the right angle is called the hypotenuse. And the other 2 sides are called legs. We mentioned that a triangle is a simple closed curve, which means that it's a closed figure that we can draw with curves. There can be no overlapping or retracing of anything. Our lines can't cross. So for example, a figure 8 is not a simple closed curve, but a circle is. It's the very simple closed curve. It's just one curve. A circle is defined as the set of all points that are equidistant from the center. The center is just the dot in the middle. You also name circles based off of their center, so this would be circle O. And we mentioned that everything is equidistant from the center. That distance is called the radius, written by R there. It's the radius. And its line segment OP is the radius. And if you go the full width across the circle, it has to go through the center, then that is the diameter. And those are the only parts of a circle. We have the center, the radius, and the diameter. If the simple closed curves only have straight lines, or line segments that intersect, then we call it a polygon. All of these are different types of polygons. If it has 3 sides, we can call it a triangle. Quadrilaterals have 4 sides, pentagon 5 sides, hexagon 6 sides, octagon 8 sides, decagon 10 sides, and if we don't have a specific name for it, you can just say how many sides it has. So if we look at this polygon here, it has 1, 2, 3, 4, 5, 6, 7, 8 sides, so that would be an octagon. But if it had more, like 12 sides, we would just call it a 12gon. It has 12 sides. Or a 100 gone, or whatever number we want, however many however many sides there are. We also need to be able to talk right now about parallel lines. Parallel lines do not intersect. We can say that two lines are parallel by writing this notation. Line L is parallel to line M. And I did want to mention that you can name a polygon just like we talked about before with triangles, just by going around, pick a point to start and just go around in order. So this would be polygon Q, R, S, T, U, and we would end with P in this case since I started with Q. We could have started with P and ended with U if we would have gone that way, or you could even go around counterclockwise. So the reason we had to talk about parallel is so we can talk about special quadrilaterals, special four-sided polygons. First, we'll talk about the square, which has 4 right angles and 4 congruent sides. You can mark things congruent by putting a little tick mark on them like that. A rectangle is like a square, but it doesn't require and doesn't have all 4 angles congruent, or all 4 sides congruent. A rhombus, also kind of like a square, but it's, instead of right angles, the angles can be non-right angles, but the sides are congruent. Rhombus just has congruent sides. Parallelograms just have parallel sides. The top and bottom are parallel, as well as the left and the right. You can mark that 2 lines are parallel by putting little arrowheads in the middle. And if you put multiple, you set to match the number of arrowheads, and that shows which ones are parallel to which. A trapezoid only has the top and bottom parallel, or left and right if it was flipped. An isosceles trapezoid has the parallel bases, but the sides are congruent to each other, just like in an isosceles triangle. And a kite has 2 sets of congruent sides, but the sides are next to each other. So the adjacent sides are congruent. And the last part of this section talks about symmetry. There's 2 types of symmetry that we'll discuss. First, reflection symmetry, which means there is a line of symmetry for this triangle. We have a line of symmetry going down the middle. Also, these other ways, all 3 of those are lines of symmetry, because if we fold them over, it would match up. Squares have quite a few lines of symmetry as well. You have the diagonals, as well as cutting it straight down in half, either vertically or horizontally. So there are 4 lines of symmetry in a square. Even with an isosceles trapezoid, you can cut it in half down the middle. If you fold that over, it would match up. That's reflection symmetry. It's the same on the left and the right of the axis of symmetry. Rotational symmetry is just like it sounds. If you rotate it, it would match up to itself. So an equilateral triangle, if you rotate, it can match up to itself. It looks the same once you've rotated it, you wouldn't even know. Also with squares, if you rotate 90 degrees, it will match up to itself. For the triangle to match up, there has to be a third of a turn, which is 120 degrees. So you could say, as rotational symmetry of 120 degrees, about whatever point, the center point, Same thing with the square. Also, a pentagon can have rotational symmetry. If it matches up when you rotate. I think my drawing of a pentagon's a little bit off, but hopefully you get the point.